Hello, good morning, all. Welcome to the third and the final demo lecture for object-oriented programming. So, just let me open the notepad. Yeah. So, yesterday's class, what we covered, I just try to note down. Yesterday's class, what we covered was very important. The first point that we covered was constructor. Okay, constructors, both static and instance constructor, we covered. Then what we covered is the ME operator. Okay, and what we covered is you can say a singleton class concept. These were the main things that we covered in yesterday's class. Okay, there are many important points that were mentioned for each of these three bullet points. So if you have missed the yesterday's class, you can just go through it on our YouTube channel. We have uploaded that particular video. Yesterday's full class has been uploaded. So if you have missed out on these three concepts, you can definitely go and have a look at these concepts. Okay. That was about yesterday. Now today's topics. Okay. Today, first thing that we are going to cover is a friend class. Okay. What is a friend class? And based on the friend class, what we are going to develop is a factory class. Okay. There is a small point that is there. Besides factory class, also there is one more thing, factory method. Okay. Factory method, I guess we have already like covered 90% of that part in the singleton class. Still, I will highlight what a factory method is in today's class, and we'll primarily focus on friend class and factory class. Okay, so let's start today's lecture with the first point, that is friend class. Okay. So what is a friend class is a what you can say, a friend class is a class which has rights to access all the members. Okay, so a friend class is a class which has rights to access all the members of the class to which it has been declared as a friend. Okay, very important statement, and we will again and again reiterate this statement. A friend class is a class which has rights to access all the members of the class to which it has been declared as a friend. Okay, so let us say an X class is declared as a friend of Y class, then class X declared as friend to class Y. This implies that class X can access all the public, private, or protected attributes as well as methods of class Y. Okay, class X can access all the public in the sense public is already available outside the class, so it's not that big a deal. But And what is important is if class X is declared as a friend to class Y, then class X can access all the public, private, and protected attributes. Attributes as well as methods. Instead of writing that, what I will write is public, private, and protected members of the class Y. Member includes attributes as well as methods. So class X declared as friend to class Y implies that class X can access all the public, private, and protected members of class Y. Okay. It is a one-way relationship. It is a one-way relationship in the sense that only class X can access class Y's public, private, and protected attributes. Class Y cannot access any of the class X's public, private, or protected attributes. That is what this implies. A one-way relationship. It is a one-way relationship. One-way relationship in the sense, I'll reiterate, if class X is declared as friend to class Y, only class X will be able to access the public, private, and protected attributes of class Y. Class Y won't be able to access any of the private or protected attributes of class X. Okay, so that is what is important about the friend class, and it's more than sufficient that you remember these 3 points. So I'll just reiterate the points. A friend class is a class which has rights to access all the members of the class to which it has been declared as a friend. Okay. The second point is just uh, like example to make you understand and clarify the first statement. Class X declared as friend to class Y implies that class X can access all the public, private, and protected members of the class Y. Okay. Members include methods as well as uh, attributes. Okay, private attributes, private methods, all are accessible. Okay, the next thing is it is a one-way relationship. That is only class X will be able to access the private and protected members of class Y. Class Y won't be able to access any of the private or protected members of class X. Okay, so let's understand this friend class concept in terms of local classes via a program. Okay, just go to AC38. More friend class. Yes, I have already created a program. So I'll create a new one, friend class. I just say two. Okay. Just for reference sake, what we'll do is I'll keep the name of this program. I guess I've already created this program, but we will create similar type of program from scratch. Okay, just for better understanding and tactical. Once you have the system access, you can go ahead and view all these programs. Okay, materials, whatever this material I'm creating right now during the conduction of this class will act as a class notes for your reference later on. So whatever program name, why I'm not able to copy the program name, but I'm not able to understand. Just a minute. Yeah, now it's fine. So we'll create a new program. Let's say two. Yeah, this program is not there. Front class demo. Remember what we are trying to understand is ultimate goal of today's class is to understand the factory class scenario with the help of friend class. Okay, so the factory class scenario will be implemented with the help of the friend class concept. So that is why first of all what we are doing is we are trying to understand what a friend class is. create a local object. So I'll not be typing the code for what you can say the factory class scenario. We'll just have a look at the code because it's quite a lengthy code, and once you have an understanding of friend class, you can easily understand this particular factory class. Okay, so just create a particular class called LCL person definition part. So we are going to use private instantiation. So this implies that section. This implies yeah, get private implies that the instance constructor is in the private section of the class. Okay, so we will not be easily able to instantiate a LCL person type object. Okay, methods constructor importing uh, say IV person for us type. So I want a particular type to be used. So what I will do is I will create the public section of the class, just like we create data, class data or instance data. We can also create the user defined data type inside the class. Okay, we can also create user defined data type inside the class using the type statement. Okay, in the public section what I will do is I will create a user defined data type. Okay, using the type statement begin of ty person. So this particular type can be used outside the class also, since it is in the public section. You can directly use this ty person outside the class also. Okay, as well as it can be used within the class. So no issues there. So first thing that it will have is a name. A person will have name and age. Okay, then DOB. Let us say DATS. Okay, let's have a PAN number, which is sufficient for us right now. So let a person have these four attributes. What I will do is the constructor is importing a parameter of the type ty person. Okay. So after this, since we have just declared the definition part, what we will have to do is we have to declare the implementation part as well. Remember, what we have declared here is it's create private. Okay, so we cannot instantiate it directly. Let's give an implementation for method constructor and a method. Okay, in the private section, what I will do is I'll create an instance attribute as well called person of type ty person. Okay, now I am not going to explain in detail what these things are, since we have already gone through these in the first lecture, second lecture, and many of the hands-on exercises that uh, we have done. Instance attribute. It will exist only for the object of the class. Okay, this is an instance method constructor. So what we are going to do is simply set the person attribute to IV person. Okay, yesterday we saw the ME concept, so ME arrow also is fine. Okay. Whatever is comfortable with you, you can use that. But if the name of the importing parameter would have been only person and not IV person, then compulsorily we had to use this ME arrow person. Okay. But in this case, it's not a compulsion since the name of the importing parameter is not same as that of an instance attribute. So no need to compulsorily use a ME operator. Okay. So that is the implementation part. Just pretty print the code for better readability. Okay, before doing this, what we can do is we can create a small selection screen to enter these four parameters. Okay, so using the parameter statement, we can do that. Okay, we will do that. The last attribute is the PAN number, so that is also of type string. So this particular statement is going to create a small selection screen for us to enter the data on the screen based on which we will be creating the person. Okay. Now, since we cannot directly create a person, we require a class. Okay, we require a class which would be able to call the constructor method. Okay. Now, since we are not using inheritance or anything like that, or even if we use inheritance here, it won't work. The only concept that we can use to instantiate this person class is the friend class. Okay, so what I want is I want a class or I want something which will be capable of calling this constructor method. Since the constructor method in the private section, I'm only left with the option of a friend class. According to the definition just now, we saw class X declared as friend to class Y. In this case, we have created the class Y. Okay. LCL person is acting as the class Y for us here in our example. So we need a class X which is to be declared as friend to class Y so that it can access the private member of the class. Private member in the sense the constructor method. The constructor method, if you call, you'll be able to get the object of the class. Simple as that. So what I will do is, friends is the keyword. Okay. LCL person definition create private friends LCL friend. Okay, what I'm doing is I'm creating another class called LCL friend. Okay, which is declared as friend to LCL person. Okay, remember LCL friend is declared as friend to LCL person. It's not other way around. LCL person is not a friend to LCL friend. LCL friend is a friend to LCL person. That is what I mentioned here. It's a one-way relationship. It is a one-way relationship. Okay, class Y will not be able to access the private attributes of class X. Class X will be able to access the private attributes of class Y. Okay, so LCL friend will have the rights to access the constructor method as well as it will have the rights to access the person instance attribute. Of course, it will need an object to access the instance attribute person. Okay, so yeah, if you try to just pretty print it, it's going to give you a syntax error that type LCL friend is unknown. Okay, type LCL friend is unknown. So that is because we have not defined a class called LCL friend anywhere. Okay, to overcome this, what we use is a simple statement in object-oriented ABAP that is class LCL friend definition deferred. Okay, class LCL friend definition deferred. It tells the compiler that LCL friend I am declaring it is a class, but wait, while compiling, the code is going to compile line by line, right? So when it comes to line number 10, if the statement is not written, it is not able to find LCL friend anywhere in the class definition or anywhere else in the program. So what we tell to the compiler using this line number 8 class LCL friend definition deferred is LCL friend is going to be defined. You just keep on compiling. Whenever you find LCL friend definition, you can then compile the class as well. But it just holds this syntax error at bay. Okay, LCL friend definition deferred. Okay, please remember this. You might have encountered in your projects many of the times, but that is what the use of the statement is. It prevents the syntax error from coming. Okay, class LCL friend definition deferred. LCL. Now I'm going to define this LCL friend method class definition and class. Yeah, simple as that. In the public section, I'm going to declare two static methods, class hyphen methods with the syntax to declare static methods. First method is get, let's say, create person. Create person. This particular method will be responsible for invoking the constructor method from the LCL person class and giving you back an object of the LCL person class. So if it is giving you back an object, what you need is a returning parameter, returning by value. If it's an object, it is RO person type reference to LCL person. Okay, if you would have done it in other way, that is LCL friend, if you would have defined it before LCL person, then the syntax error would be LCL person is unknown. Okay, so that time you had to change the this particular statement to class LCL person definition default. Okay, I'm just reiterating what I said. If LCL friend is defined before LCL person, in this case, just we'll do that so that you'll be able to understand what I'm trying to say. Okay, I'll just comment out the statement. No need for the statement right now. Also, I will put an implementation part so that I won't get a syntax error in that regards. LCL and implementation and class, and then just method person. Let the implementation be blank. So now if I I'll print the code. If you do a syntax check, now the error is type LCL person is unknown. Okay, line number 12. Because it has not found LCL person while compiling, the code comes from top to down. LCL person, such type of class doesn't exist till now. Okay, the code has not reached compiling up till line 20 from where the LCL person definition starts. So this particular line number 8 has to be changed then to LCL person definition default. Okay, now the error is gone. Please remember this, very important, definition deferred. The class which is going to be defined at a later stage is to be declared as class, the class name and then definition default. Currently, I'm not going to do in this manner, so I will revert my code to earlier and just say LCL friend definition default. So first we are defining the LCL person class, then we are defining the LCL friend class. In the LCL friend class, we have created a create person method, which is returning a reference variable of type LCL person. So this particular method is responsible for instantiating the LCL person class. Okay. Yeah. But to call the constructor, if you check, the constructor has some importing parameter here. Okay. And we also need to have an importing parameter for create person. Importing IV person. Okay, type. Now type of this IV person is TY person. This TY person is there in the class LCL person. So what I will do is I need the importing variable to be typed according to TY person. So I will just write the name of the class, member selection operator for static attributes and methods, TY person. So one of the important thing that you need to remember is that if you want global types to be declared, if you want global types to be declared, if you want global types to be declared apart from dictionary, if you want global types to be declared about apart from dictionary definitions, what you can do is you can create a global class and declare types there. Okay. For example, if you check SC24, okay, I guess we can have DPC extension class somewhere. MPC, yeah, we have something. So this is a global class. I don't know what this class is. It is definitely a class from an OData service somewhere declared in SEGW, but nothing is there, unfortunately. Need to check DPC. Add something. Let's check this. Here also nothing is there. So actually, what we generally do is if you want something to be declared globally as a data type, but not in the dictionary. So what you do is you open up or you create a global class in SE24, and in the types section you create the type. Okay? You create the type. So that type will be directly available anywhere in any of the programs you try to use in this manner. Just यहाँ पे what will happen is global class name will be used here. Okay, the member selection operator and the type that is member. Okay. So classes can also be used as a container for global constants. Okay, it can be used for like defining global types. Okay, table types, etc. So later on, we'll have a better look at it when we have global classes with us. But right now, LCL person, I'm trying to use TY person data type outside the class LCL person. That is why class name, member selection operator, and then the data type. Okay. So that is all about create person method. Now what we are going to write inside the create person method is we are going to instantiate the LCL person class. So for instantiating, the statement is create object, okay, RO person. Exporting IV person is equal to IV person. If you just do a syntax check on this, it's giving you no error. Means create object is the only statement by which you can invoke the constructor. There is no statement like call method constructor, something like that. Very important point to remember. Create object statement. It is the only statement, or new operator is the only statement by which you can invoke the instance constructor. There is no other separate statement like call method or uh, object arrow then the constructor. No, the statement is create object. It will always invoke the instance constructor, and I am passing the uh, mandatory importing parameter. Okay, simple as that. Now what I need to do is here I need to create the program itself. I have to create LO person, type reference to LCL person. Okay. One more important point I need to do here is LWA person, type LCL person, member selection operator, get the data type TY person. So I am declaring a simple work area type of variable, structure variable you can call it as a structure variable. The structure variable. So simply fill in the values that are coming from the selection screen into the structure variable, pass the structure variable to create person method. Create person will in turn call the instance constructor of LCL person, which will return a new object to you. Okay, simple as that. So LWA person. Design patterns are very important. You need to understand this very well. These are very trivial examples. Real-time scenarios will be much more complex than this. That time you have to recall all these basic concepts to gain a proper understanding of the scenario that you are dealing with. Four attributes are there: name, age, and DOB is there, and finally PAN is there. Age, DOB, P underscore DOB, yeah, and finally P underscore PAN. So I have filled in all the values coming from the selection screen into the structure LCL friend, all the create person method. Create person method, we need to export something. What we need to export is LWA person, and what it is going to return to us is our person object, LO person. Yeah, so that is how we are going to create an object. Let's check whether we have any syntax errors. No, we don't. Now if you want to get the attributes of a person, what we are going to do? Okay, since the attribute that is there, instance attribute is person itself, which is present in LCL person class. There is no way to have access to this person's attributes. Okay, first of all, let's debug this. Let's try and understand what is happening. Unnecessarily writing too much code will create confusion. You need to activate the class first. Place a breakpoint, execute, type in some name here, age here. Okay, date of birth, you can just take whatever value is there. Okay, calendar value, the PAN number, any string you can take, and execute. Just check whether the structure is filled. Yes, it is filled. No issues. Once you do an F5 on this, create person, the control goes to create person. Further, IV person is now populated with whatever values you have been sending in with the work area. Just F5, it's going to give a call to the constructor of LCL person. There the control goes over there, and then do an F5. So you can check here ME, where it is there. Yes. So ME is the new object that has been created. Okay, of type LCL person. The attribute we can see here is named as person. That is what we named while creating the attribute here. This is that attribute. Okay, it's a deep structure. That is what it is saying. Why it is saying it is a deep structure is because we have string type variables within them. Okay, two of the attributes or components of that particular structure are string. So string is always considered as a deep entity. Okay, so that is why it is calling that structure is as deep structure and not flat structure. Okay. Next important thing is, yeah, F5. uh, F5, come back to the create object. RO person, me is no longer, see, what this symbol means is invalid variable. ME is no, we cannot use ME variable here. Okay. Why we cannot use ME variable here inside the create person method is, if you recall yesterday's class, what the notes or whatever I told you, what the notes said is that ME can be only used inside an instance method. Okay? ME can only be used inside an instance method. Since create person is not an instance method, me is an invalid variable inside the scope of this create person method. Okay, so that is why it's showing me as an invalid uh, attribute or method. Just give me 2 minutes. I have a power outage. I'll just switch on the emergency lamps. Yes. Hold on. Yeah. Okay. We are back online. So what we were discussing is me is not a proper use. Means we cannot use me inside a static method. Okay. So do an F5. Okay. So we are able to instantiate LO person or LCL person class. Okay. So what if you want the attributes of this LO person object that you have created? For that, you have to create another method. You have to create another method here, get person, and based on that, you can get the attributes. Okay. This particular exercise, I will leave it to you guys. Okay, how you are going to get the attributes back and print them. Okay, let us say I clear this particular work area, clear LWA person. If I clear this, what is going to happen is I no longer have access to the attributes of LO person. Okay, those are permanently stored in the private attribute person. So if you want to print the attributes uh, using a write statement, you no longer have access to those attributes. So what you can do, I'm not going to code that, okay, because I want you guys to understand this example. I'll share this code in complete code. It's a complete code only, but you have to add some functionality to print out the attributes. Once they are set into the object, you will have to have some mechanism by which you are going to get those attributes back and print them. Okay, so I'm not going to write that code. It's a simple thing. Actually, you have to create one more method inside this friend class and you have to call that and get those attributes returned back to the program. Okay, simple thing. Next activity. So this is the name of the program. I'll just keep it with me. Later on, you can use that. Copy the name. Okay. So that was about your friend class. So friend class, what is a friend class? All these 3 points are very important. How to create a friend class scenario, that also has been uh, explained here. Okay. So the important point now is the factory class scenario. Okay. So I'm not going to write the code. I already have the code with me. We are going to try and understand that code. That too, if the power permits, we'll be able to do that because we are running on battery backup right now. If check whether we have that program. I don't think this is my program, but still, I'll have a look. No, it's not definitely my program. Just let me. I'll just stop the screen sharing. Let me get my program. Yeah, okay, got it. I'll share the screen back on. So this program was developed a couple of days back. Okay, factory class design pattern. It uses the friend class. Okay, I'll just copy paste this entire code in a new program. I guess I created it in some different system, so I'm not able to find it in this particular system. Okay, I'll just copy paste it. It's no point in writing such a whole huge code back again, since the only thing that we need to understand is how the factor class scenario is implemented. Yeah, type is executable program. Save. Here as a local object. Since this has been copied from a Word file, I'll download that file. I'm not able to do. Just hold on. Just bear with me for a moment. Okay. Since we are experiencing power outage, just bear with me for a moment. Yeah. Just let me share my screen back. Just let me know when you guys are able to see the screen. Is the screen visible? Hello? Yeah, okay. Okay, thank you. So, yeah, I've just look at the scenario now, how it is. We have developed a selection screen. On the selection screen, we have two parameters. Okay. Remember the concept that we are trying to understand is factory class. Okay. So what is a factory class, first of all, that we'll understand? Factory class is a class which is capable of giving you instances of other classes. Okay. Is capable of giving you instances or objects of other class or classes. Okay, class or classes. So what we are doing here is we have a class called LCL factory, okay, which will be acting as a factory class. LCL factory will be acting as a factory class. We have declared it as a friend to LCL class 1. Okay, we have two classes here, LCL class 1, LCL class 2. To both these classes, LCL factory is declared as a friend. Now we know what are the implications of declaring a class as a friend to another class. We just now saw it. Okay, so LCL factory, since it is declared as friend to class 1 and class 2, the implications are that LCL factory will be able to access all the private attributes public attributes and protected attributes for both the classes, LCL class 1 as well as class 2. Okay, so that is what we have done here. LCL factory is declared as friend to both these classes, LCL class 1 and class 2. Okay, so what is the structure of class 1 and class 2? That we'll see now. In the public section, we have a method called get attribute. Okay, uh, for better understanding, if you read it carefully, you will find that this get attribute method is an instance method. Okay, it's an instance method. An instance method. It has a private section as well. Class 1 has a private section in which it has a private attribute. Also, it has an instance constructor within its private section. Since we have declared the instantiation as private, the constructor is going to be in the private section. These all things we have gone through in yesterday's class. What is create private and all. Okay, constructors also we have gone through in the previous class. So in the implementation part, there is the implementation of the constructor method, which is simply setting the importing parameter to the class attribute. Sorry, not class attribute, instance attribute. And then there is a instance method get attribute, which simply returns the value of the attribute. Okay, simple architecture of the class, no confusion here. Same thing has been done with class 2. The structure of class 2 is also same. I've kept it very simple to highlight the factory class concept only. The same as that of class 1, class 2 has its constructor in the private section. It has an attribute which is in the private section, instance attribute, and get attribute is the public instance method for this particular class. Okay, implementation is also same. So class 1 and class 2 are effectively uh, like same only. Okay, the name is different only. Okay, then comes the factory class. Okay, LCL factory, remember it has been declared as friend to both these classes. Okay, in the definition section, what we have is in the public section, what we have is class 1 data object is there, type reference to class 1. So there is a static method get instance. In that what we are passing is the class name and the value. Okay, what it is returning is an object reference. It is returning an object. Now if you look at this particular uh, thing that I've written here, type reference to object. So what is this type reference to object? Object is the supermost class. Okay, object is the super class for all the classes in ABAP. Okay, object is the super class for all the classes in ABAP. Remember. So we will have a much detailed understanding of what is a superclass, what is a subclass, what is the implication of a class being a superclass to a subclass, and what are the implications of a subclass being a child of a superclass. All these concepts we'll cover during the inheritance part. But just for now, object is the superclass for all the classes in ABAP. So what this get instance method returns is depending on the class name sent to it, either class 1 or class 2, it is going to instantiate the object of that particular class depending on the class name. Okay, and IV value is simply used to pass the attribute. Okay, since both the attributes in class 1 and class 2 are of string types, so we are going to simply pass the value of that particular attribute in this importing parameter. And the first importing parameter is very important. It is passing the class name. Which classes object you need to instantiate? Whether you need to instantiate class 2's object or whether you need to instantiate class 1's object. Okay, that is what this particular parameter is going to let you know. Okay, the returning parameter is going to pass the object of whichever class you have sent here. Okay, as the importing parameter. So the implementation of the get instance method, what it does is simply it's a case on the importing parameter IV class name. Okay, if it is LCL class 1, you create an object of class 1. If it is LCL class 2, you create an object of class 2. Simple as that, and return that object as it is, RO object. Okay, that is what the logic has been written. So in all, we have three classes with us. The first class uh, is create private. The second class also is create private. So we cannot directly instantiate the objects of these classes. Okay, for that we require a friend class. So what we have done is we have created a factory class and declared it as friend to both these classes. Now this factory class can instantiate both these classes. Okay, so we have designed a method called getInstance inside the factory class, which will create the object of the respective class depending on what is the class name that you are passing to it. Okay, so yeah, simple as that. getInstance method को call किया है यहाँ पे at line number 91. uh, Whatever is passed as the class name on selection screen, that has been passed as the importing parameter, to this getInstance method. Whatever value on the selection screen is passed, that has been passed as the importing parameter IV value to the getInstance method. The object is instantiated and passed back. Okay, again LO object is type reference to object. So the code is written in a much more dynamic way, but so what we have written here is, if the class name passed on the selection screen is class 1, then you can collect the, so this particular syntax is called downcasting. Okay, again we are going to cover this downcasting during inheritance, so no need to panic that directly downcasting syntax has been used here. So this will be covered in detail whenever inheritance is taught, whenever abstract class is taught, whenever polymorphism is taught. Okay, somewhat inheritance concept has been used in this particular program, along with uh, a very small degree of polymorphism. Okay, so the syntax that is being done is used here is downcasting. Okay, here as well as here, both downcasting is done. So you can debug this program as well to get a better understanding. First, let us activate this. Let's see whether we have any syntax errors. No, we don't have any syntax errors. So I'll just try and instantiate the class 1. Class 1 and pass some value. Since it's a string, you can pass any of the values. Just execute. So let's trace our execution from inside the get instance method. Okay, these are the values of the importing parameters that we have got from the selection screen. Just press an F5, go inside the get instance method. Okay, IV class name, it is LCL class 1. So the control will go in the first when. Okay, object is not yet instantiated because call to the constructor has not gone. Okay, so press an F5, it will take you inside the constructor. Set the attribute value. Remember, the constructor of class 1 is getting called here. Okay, do an F5, object has been instantiated. See, RO object. So RO object, actually the typing is done using a superclass. Okay, but internally it holds the um, instance of subclass LCL class 1. Okay, so object type reference to object means object is the superclass for all the classes. Okay. In ABAP, whatever number of classes are there, object class is the superclass for all those classes. Okay, so it is capable of holding the reference of any of the subclasses. Okay. Hence, it has been used. Since here the um, class that is to be instantiated is dynamically determined using an importing parameter, we had to do this. Okay. So now RO object is the reference variable which is pointing to an object of type LCL class 1. Okay. No need to panic. We are going to cover this in the inheritance part. We are going to cover upcasting, downcasting, okay, polymorphism. So currently small part of it has been used here. So yeah, we have an object of class 1 because we passed the IV class name as LCL class 1. That is why we have an object of LCL class 1. Now remember, I want why we need to downcast here is because LO using the reference variable of LO object, we will not be able to call the get attribute method. The get attribute method we are trying to call from the class LCL class 1. Okay. If you try to call the get attribute method using the reference variable of a superclass LO object, it won't be possible. So what we need to do is we have to collect the superclasses reference variable into the appropriate subclasses reference variable. Okay, so that is done using downcasting. So LO class 1 is right now initial. I have collected the reference. Okay. Now I can definitely call the get attribute method. Okay, if LCL class 1 is not the child class of object class, then this would have resulted in a exception and dump. Okay, since I have not done any exception handling here, it would have resulted in dump. But this statement executed because LCL class 1 will definitely be an child class of the object class. Okay, since I told object class is the superclass for all the classes in ABAP. So LCL class 1 is definitely one type of local class in ABAP. So it definitely is going to be a child class of the object class. So that is why this statement worked 100%. Otherwise, you have to be damn sure that the reference variable on the left hand side of the downcast operator is of the type subclass of the reference variable on the right hand side. Otherwise, it's going to result in a dump. Okay. The write statement has been executed. For write statement, we have get attribute method executed as a functional method. So it's going to return you the value of the attribute that you have passed on the screen, and it's going to print out the output. So similarly, if you change the input on the selection screen, if you pass it as class 2, you will get an object of class 2. Okay. So that is how a factory class is. A factory class is capable of returning instances of particular set of classes. Okay. In this case, we have only two classes, class 1 and class 2. So the factory class is capable of returning objects for both of these. Without the factory class, you cannot instantiate the classes class 1 and class 2 because the instantiation is declared as private. Okay, and you also cannot access the attributes, private attributes, because unless and until you create an instance of the class, you won't be able to call this get attribute method in any of these classes, because the get attribute method is an instance method, and without the object you cannot call the instance method as also. So there is no way you will be able to create an object of these two classes, class 1 and class 2, uh, besides using the factory class. Okay, so that is your factory class design pattern. Okay, that's all for today. Okay, any doubts in this so far? I know today's class and yesterday's class were quite heavy on the concepts in object oriented programming. Okay, so yeah, any doubts in this so far? I know there are plenty of doubts. Okay, let's take up the doubt in the next class. Okay, regarding the next class, I would like to highlight here again that today is the last demo lecture on advanced ABAP, and we are covering object-oriented ABAP in that. Yesterday also I had highlighted that we are going to uh, like stop the demo lectures now. Do we have? Yeah, please share the factory pattern program if possible. Yeah, sure. Uh, Everything will be shared. What uh, I want to highlight here is that please confirm your admissions right away, since today is the last demo class. Uh, we will be sharing the links to the next classes only to those guys or students or candidates who have confirmed the admissions. Okay, so I'll be sharing the links for the demo lectures for advanced ABAP today also in the report. Definition of factory class. Yes, I have already given the definition of factory class here. A factory class is capable of giving you instances of other classes. Okay, other classes or of classes. Okay, this is a design pattern. Okay, so definitely what you need to understand here is that uh, you have to declare that factory class as friend to the set of classes you want to get the instances from. Okay, so it will be like solution dependent or framework dependent. So these concepts are used to implement the framework. So the framework is designed in that manner. Okay, so likewise I have designed a small little framework here to demonstrate how the factory class works. Okay, any other thing in the chat? Yeah. So I was saying that please confirm your admissions. The links will be shared in the group chat. The group chat will be accessible to you guys. Uh, Also, the number will be shared. YouTube links will be shared for whatever demo lectures have been conducted so far for basic ABAP as well as advanced ABAP. So please do confirm your admissions this weekend itself. Okay. Yeah. Thank you and have a good day.